Hey folks, out here this morning in the shop, stealing a little bit of time away from the family, trying to face some of these unfinished projects. And the one I picked on today is the adapter ring for the transmission. This GM adapter that I have for the 4BT was developed by Cummins for the turbo 400 transmission. And I've got the 700R4 transmission, a little later generation, and the spacing on the torque converter, between the torque converter and the flywheel, different spacing between the 700R and the Turbo 400. So, you know, of course, there's a solution on the internet. It doesn't take much poking around to find that somebody's already developed a solution for this, and not expensive. So I ordered one, got it in the mail, opened the box, and was extremely disappointed. Well, let me show you what came in the box. This ring cut out of 3/16 steel, and it was cut on a plasma cam, CNC plasma cutter. And well, you can probably see the holes are everything but round. So I was worried a little bit about this thing not spinning so true, and decided that I would make an attempt at cutting a new one. And this is what we're going to do it with. It's a piece of flat 3/16. I'm going to set it up in the mill on the turntable and cut the outside diameter here with a mill bit, and the inside as well as drill the holes while it's on the turntable. And hopefully our product will be quite a bit truer than this plasma cam, plasma CNC cut ring. This ring, like I said, hooks the torque converter to the wave ring. The wave ring then hooks up to the back of the flywheel. And I believe the reason for the wave ring, the original flywheel obviously was not drilled at the same diameter as the torque converter, and there's also a space that has to be made up for due to the way the adapter plate is mounted to the back of the engine. I think that's the theory on all that. But anyways, if you can tell, the wave ring bolts to this adapter ring, and then this adapter ring will bolt to the torque converter, and then this side of the wave ring will bolt to the back of the flywheel. So not rocket surgery here, but still, I thought the tolerances, or the the lack of tolerances on these holes was a little bit outside of my comfort zone. So let's take a swing at it, see if we can make it a little better. I've already taken a little bit of time here and put some Daikin on this plate and marked the center, and roughly marked the inside diameter and the outside diameter of my ring. I'm going to make it a little bit wider than this one that I bought, just so it's the same diameter as the wave ring here. So let's get over to the mill and get this set up and get to work. All right, quick stop here at the engine before we get to the mill, just to take some dimensions. I didn't like the idea of taking the dimensions off that adapter plate that I bought, just because of the way the holes are, and pretty tough to measure, you know, when the holes are oblong and not round. So this is what we're trying to do. This wave ring bolts to the flywheel with 6 holes, and they go through the back of the flywheel, from the front of the flywheel through the wave ring. And then these 6 holes will attach to our adapter plate through the 6 holes here, so 60 degrees apart. And we know what that dimension is. That's 11.5 inches. Those are, these are machined well enough that we can take a dimension off of that, and they're 180 degrees out. So that was 11.5 inches from center to center of those holes. Now let me swing you around here to the torque converter and we'll check out those holes. All right, so there's only 3 holes in this torque converter for the 700R4, and that is shown on this wonky adapter plate here. I've marked it TC for torque converter, and with a quick search on the internet, I found out that these are supposed to be 10 3/4 of an inch. So from center here, well, it'd be from center to center over here if we had 180 out, should be 10 3/4 of an inch. So what would that be? 5 3/8 from the center here to the center of this hole here. And just a quick trip around with the ruler, that double checks with what was on the internet. So I think we're safe to drill our new adapter plate with that dimension. Okay, we're all set up over here on the mill with the turntable bolted down and secured, and then I've mounted the plate on the turntable with a couple of pieces of sacrificial material underneath it. It's just 2 pieces of 1/4 inch OSB, or actually it's MDF, and that way we can plunge all the way through it without getting into the turntable. But I marked it out with 4 different rings. This is the inner part that will cut the ring off, and this is the ring hole, or the groove, or shoot, ooh, like my kids say, English is tough. The inner ring here is for the torque converter, that's 10 3/4. The outer ring here is for the wave ring, and it's 11.5. And then of course the very outside ring here is just the outer part of the adapter plate. Now I don't have a DRO on my mill. This is old school here. I actually had to use a ruler and a compass to mark this out, but I think it'll be fairly accurate. At least it'll be more accurate than CNC plasma cam. It'd be really nice if somebody set this up in a in a Haas machine and milled these things out to some real precision. Get the programming done. Wouldn't take much effort to knock a few of these things out and put them on the market. I don't have that capability, so here we go. I'm going to make one for myself. All right, 3 holes. That's all we need here is 3 holes for the torque converter, and they're 360 divided by 3 is what, 120. So 120 degrees apart. Let me check the size of the bolt that goes into the torque converter so we know what the final dimension will be. All right, looks like the bolts are 3/8/16 on the pitch. Not that matters for drilling this hole, but we got to drill 3 3/8 holes, and 360 degrees. That's 120 degrees between each hole. So I've got the index on the rotary table set at 0. So we're going to start with a starter bit here, and just go around and start 3 holes here, 120 degrees apart each. All right, we have 6 of these holes to drill for the wave ring here. So I've moved it out, moved the table of the mill out until we're lined up with this outer mark that we made. at 11.5 inches, and I just laid the old, or the the bad adapter plate on here just to kind of make sure I'm headed in the right direction, and I am. So if these are 120 degrees apart, 360 divided by 3, 120, these will be half that, so 60 degrees apart. So this was the hole that we started at 0 on the index. I moved 30 degrees, which puts me the starting point here, and then we'll go, we'll add 60 degrees to each one of these holes until we work our way around, and should have 6 holes in that outer, on that outer mark. And again, let's see, I gotta check to make sure that I got the right drill bit. I want to drill the right size hole, so let me double check that. Yes, those are 3/8 bolts as well. So here we go, 6 holes, 60 degrees apart on each one of them. All right, we're set up here with a 1/4 inch 4-fluted end mill here, and I'm not going to try to cut the full 3/16 all at once. I'm probably going to do it in about 4 passes, taking my time and just feeding it with the rotary table. So let's get started here and see how it works. All right, that was kind of rough on the equipment. It was tough. It took a whole lot more passes than I thought. I wound up getting the my cordless drill to drive the turntable, the rotation of the turntable, and we gnawed our way through it like a beaver with dull teeth. But what I'm going to do now, as you can see, right here in this point, there's a flat spot here, and I came plush on this side of the line so I could clean up this edge. And now I'm going to move the table, well, it'll move it this way. Can't see my finger, can you? Well, you know what I'm talking about. Move the table that way, and then rotate the turntable more, just to kind of clean up that edge, and I'll make it completely around that direction. I'll take a couple of passes, regular milling passes, then I might even try a, well, there's a lot of backlash in that turntable. I was going to try maybe a climbing mill, but let's see what kind of finish we get. We don't really even need a good finish here. It's just all for practice and all for fun. But let's try a standard milling rotation first, and then we'll see what we get, where we need to go from there. All right, well, I can see resemblance of a little better finish here. It looks pretty bad in the screen just because it's such a close view. But what I think I'm going to do to try to improve it is change bits. I'm going to go with a little bit bigger diameter bit, maybe a little bit more rigidity, and probably, heck, it'll be just sharper. So let me swap out mill heads or mill bits, and we'll see where we go from there. All right, got this Hoss dog loaded up here. It's a 5/8 6 flute, and that certainly ought to be rigid enough. Let's give it a whirl. Well, that wasn't perfect. Rigidity is everything when you're milling, and there's just a lot of backlash in those gears. It's really not meant for that that kind of process. Works pretty well on aluminum. I've used it a bunch that same way, you know, milling out round stuff on aluminum. But this steel, it just does a lot of chattering. So I think it's the best finish we're going to get, and that's fine. I'll clean it up a little bit with the sander and be okay with that. Now we've got to turn our sights on cutting the inside circle. We're going to have the same issues cutting the inside of the ring out as well. But let's see what we can do with it. I think I'm going to stick with this 6 fluted 5/8 mill. It's going to have to cut a lot of material out of there, but it's sharp and it's an end cutting mill, so I can plunge cut it in there. But I think we're going to take it real slow and just ease it in and take lots of passes. Now I've got it lined up with my mark on the inside. I won't be able to do any cleanup cuts with it, because once the ring comes loose, that's it. Whatever finish we have, that's what we have. We'll have to clean the rest up with the sander. So let's get going. Well, that worked out pretty well. Definitely more precision than this one. I pulled it off and buffed the edges with the flapper disc just to kind of take the chatter marks out of it. And then I used a DA sander to hit it again to smooth it up on the faces of it. And along this edge, really couldn't do it on the inside. Now I did run a drum sander on the inside of it to kind of chamfer it a little bit and to clean it up a little bit. And I've already tried it on the torque converter. Couldn't wait for y'all. Sorry, I was too excited. But, but it did fit. It fit perfect. It's awesome. So I did save this fitting for y'all. Let's see if we can, if we had any luck here. Let's see. There's one. We'll get one hole there. Uh-oh. What's going on here? Oh no. What is going on here? Huh. Oh. Goodness gracious, that's what's going on here. Trying to put it on the wrong side of the wave ring. Woo! Nervous about that. Alright, well I gotta get some bolts for that. Golly, that was starting to really cook my brain there. So, alright, whew, it fits, it fits, it fits. So, whoops, got that one in the wrong hole. There we go. How do you like that? Golly, that was a little scary there for a minute. Thought I had really made a major calculation error there, but apparently not. All right, so you know, I could almost rivet that together. Gosh, I may have to ponder that for a while. Well, that would make it very difficult to get these bolts in. The bolts going through to the torque converter if we permanently riveted this together. So probably best not to do that. But I'll check some clearance issues to see what I have to use for hardware to bolt this adapter plate to this wave ring. And that should be it. Maybe a little bit of paint, a little pretty it up a little bit. But all right, that's it. The Cummins 4BT or 6BT GM adapter plate to the 704 or R4 transmission. Have a great day, guys. Hope you enjoyed.